Okay, Algebra 2 people, here's our last section for the chapter where we kind of put everything together. This one is about writing the equations of a quadratic from given data, from information. So we've talked about there's three forms. You have the standard form, vertex form, intercept form. The main two when you're writing an equation is going to be either vertex or intercept form. So let's look at those two. So when you are given a point here and the vertex, remember your vertex in vertex form is HK, you do want to use the vertex form. So this is, remember what your vertex form is, y equals a x minus h squared plus k, where hk is your vertex. So to find the vertex form given a vertex and a point, what you're going to do is that means you're given an HK and you can then find a point on the graph. You plug those in, so these get plugged into the equation, and then you have to solve for A. And when you're done, you basically put everything back, keeping your y and your x in the equation. The other form we're going to focus on is intercept form. Now, we changed the P and the Q to R1 and R2. I know your book uses P and Q. And then you are given a point as well, remember, so this will come to you as XY. So intercept form, remember, is y equals A. It's sort of like your factored form, x minus R1, x minus R2. Remember where the vertex is halfway between those roots. So again, when it comes to you in this form, so you will be given, or you can find R1 and R2 from your graph. You're given an XY, you can find it from the graph. You want to plug all those in, and again, solve for A, which is what we're going to do in our examples below. All right, and then the last form is when you are given 3 points. So whether it's from the table of data, which is what we did in the last section, this is when you go to standard form. So remember that standard form is y equals ax squared plus bx plus c. So given those 3 points, that's when you have to solve a 3 by 3 system after you have plugged in for x and y from the 3 points. And we will practice one of those as well. One thing I think I didn't write up here, let me just emphasize again that, so this is going to be vertex form, this first one. Second one we call intercept form, which kind of makes sense. You're given the intercept, so that's our intercept form. All right, so let's look at this first example. The graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. Write an equation of the parabola. So he lands in a net 90 feet from the cannon. What is the height of the net? So first thing we're going to notice is here is your vertex. So let's go ahead and identify what we know. We know HK is going to be 50, 35. And we know a particular point. If you can ever use a point that has a 0 in it, that's always a good thing. So this was our vertex, and here is a particular point. That point is 0, 15. So writing our vertex form, so y equals a x minus h squared plus k. We can now plug in those given values. So the y value, I like to label it a little bit above. Let me use this. So this is our h, this is our k, this is a particular x, this is a particular y. So we know that 15 equals, we're trying to solve for A. The x coordinate is going to be 0 minus the h is 50 squared plus the k value is 35. So the first thing we have to do in solving this is we subtract 35 from both sides, and that is going to give us a negative 20 equals a times 50 squared, negative 50 squared, but it's going to come out positive, which is going to be 2,500. And then we divide both sides by 2,500. And we could simplify this, which is not a bad idea. The zeros can cross out. And this also reduces negative 2 over 250 reduces to negative 1 over 125. And from there, we have our A. So we can put it all together, and that's going to read y equals negative 1 over 125. So now we leave x in, x minus your 50 squared plus 35. So that represents the relationship of every, wherever that person is being shot out of the cannon. Okay, so then it asked us, the performer lands in a net 90 feet from the cannon. So that's an x value. So what we're going to do is we are going to, I kind of ran out of room here, we're going to plug in, do it right over here. If x equals 90, what does y equal? So y would equal, and this is something you can plug into your calculator. I'll kind of write out what we're doing. Negative 1 over 125, 90 minus 50 squared plus the 35, and when you plug that in, you will get that y equals 22.2 feet. Okay, so that's how you would use vertex form. You find your vertex, find a point, plug everything in, solve for A, then put it all back together. All right, the next one is where we actually have a meteorologist creates a parabola to predict the temperatures tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. So notice here we see two of our intercepts, and we're going to write a function then using the intercept method. So the intercept method is x minus root 1, x minus root 2. So let's identify what we have. We have that root 1 is the x-coordinate is 4. Root 2 is going to be 24, so that's 24 hours after midnight. And then we also need another point. We need a particular x and y so that we can solve for A. So we have a point up here, an intercept. So we know that a particular xy value is going to be 0, 9.6. That's our xy. So when we plug all this in, we're going to have, so the y value will be 9.6. A is what, again, we're trying to solve for, so we'll leave that there. X is going to be 0, that's going to make it nice and easy, minus the first root, and then 0, still the same x value, minus the other root, and then we want to simplify this out. So we have 9.6 equals A times, this is going to be a negative 4 times a negative 24, so 9.6 equals A times, turns out that's going to actually be positive 96, negative times a negative. So dividing both sides by that gives us A equals 0.1 or 1/10. I don't really care whether you use a decimal or a fraction, but we do want to then put it all together. So putting it all together, we get y equals 1/10 x minus 4 times x minus 24. And that would be your final answer, because you want to have an x and a y in your final answer. Now, it also asked us, what is the coldest temperature? So looking at the graph, the coldest temperature happens down here, actually at the vertex. So what we can do is go ahead, actually, it looks like the coldest temperature, yeah, is at the vertex. So remember, the vertex happens halfway between those two roots. So the first thing we're going to do is find the x-coordinate of that vertex. So to do that, we take the two roots and we add them together, divide by 2. So 28 divided by 2 is 14. So that's the x-coordinate when that happens. The corresponding y value, we have to then plug in, whoops, sorry, that was a mistake. Let's go back on that one. So y equals 1/10, and we are plugging in x is 14. So 14 minus 4, 14 minus 24. So that gives us 1/10 times 10 times -10. So these will cancel. So the coldest temperature is going to be -10 degrees Celsius, since everything is measured in Celsius. All right? All right, our third example has to do with the third type we can get, and this is where you would be using standard form. So remember standard form, y equals ax squared plus bx plus c. So we're going to use 3 points. It's always nice if you can use the 3 smallest x value points, and especially if you can get in 0, because 0 gives you a gift right away. So what we're going to do is we're going to plug in for the bottom row gives us the y values. So I know that 6 is going to equal, now I'm plugging in for x the 0. So in this case it's going to be a 0 plus a 0 plus c, and that's the gift if you're ever given a 0, because right off the bat we know that c is 6. So when I go to write my other equations, I'm already going to include that. So the next coordinate is going to be the y value is 22, the x value is 2. So 2 squared is 4, so 4a plus 2b, because we're plugging in 2 for x, and for c we're going to automatically just plug in the 6 since we know it's there. And then the third equation is also going to have a y value of 22. Now my x value is 4, so 4 squared is 16, and then it's just 4b, and again I'm going to plug in that 6 right away since we already know what c is. So we can simplify these. Let's move our 6 to the other side. So both these equations are going to read, actually, well, I'm going to write it right here, it's fine. 16 equals 4a plus 2b, and this one is going to be 16 equals 16a plus 4b. So we're really only having to solve a 2 by 2 when you're given an initial point of 0. So I'm going to continue the work up here. So we have 2 equations. We want to eliminate one of the variables so we can solve. So I'm going to multiply this first equation by -2. So I'm multiplying by a -2. Make sure you multiply everything in the equation. So I'm going to get -32 equals, and again a -2, so this will be a -8a minus 4b. The second equation I will write right underneath exactly as it was. That's our 16 equals 16a plus 4b. So that when you add those together, I get a -16 equals 8a. So we know that a equals -2. And once you get that first, everything else is going to be back substitution. So I can plug this, I'm going to plug it right into here. I know that I have 16 equals 4 times -2, because we now know what a is, plus 2b. So that's a -8. -8 plus 2b, so we're adding 8 to both sides. So 24 equals 2b, which tells me b is going to be 12. And then we already know that c is 6, so we can put it all together. So we have y equals -2 x squared plus 12x plus 6. That would be the final answer. So again, anytime you can get an x value of 0 to use, it's going to be a gift because it means you can then automatically find out what your c value is. And then you're just solving a 2 by 2, so it's not so bad. Okay, the last little bit we're going to talk about, so we've been given data. You get a vertex and a point, or you get a couple roots and a point, or you have a set of data that you know is quadratic. You can come up with the equation. But what if they don't tell you what type of data you have? You just have a table. We have to figure out, is it quadratic or is it linear? Because that's really all we have so far. So we're going to do what we call looking for constant differences. So notice here in this example, each one of my x values is going up by a constant rate of 1. We've done this with the linear functions. But now look at what happens before. If this were linear, when I take that constant difference, so 9 to 4 is, I'm going down by 5, then I'm going down by 3. I'm not going down by the same amount. As a matter of fact, I'm even going down and then I'm going back up. There's not one number. If that first number was the same, that would tell me that I had a linear. So we know this one is not linear. But then the magic happens. I take a second difference of those, and notice -5 plus 2 gives me -3. Plus 2 gives me -1. So all of these suddenly have a constant, what we call a constant second difference. That is the identification of a quadratic. So you're always looking for a constant second difference. And we aren't necessarily going to do it this year, but if I went further and found a third constant difference, that would tell me I have a cubic. Fourth constant difference would tell me I have a quartic. So that's one of the ways you can use your data to determine what type of function you have. So what we're going to do in these examples, so we're going to look for the differences in the x's and the y's and try and determine, is it linear, is it quadratic, or maybe it's neither. So let's see how this works. So this first one, I'm going up by 1, going up by 1. So these all look very constant. Down here I've got plus 10. Here it's going to be plus 30. So already we know it's not linear. This next one, 135 minus 45, I believe, is going to be by 90. I'm going up by 90. Then I'm going to go up by 190, 270 actually. So this one is actually growing. If I go to try and take a second difference, notice it's not going to be constant either, because that's going to be plus 20, that's going to be plus 60, so it's not linear, because your first difference was not the same. It's not quadratic. Something you will find out in a future chapter. This one, so right now it's okay for you guys just to say, so it's neither. Turns out it actually is exponential, but we'll be learning about that in a chapter second semester. So it's okay for you guys just to right now say it is neither. Not linear, not quadratic. All right, let's look at the second example. Here I've got plus 3, plus 3, plus 3. Everything seems good. Down here I've got minus 6. I'm going down by 6. I'm going down by 6, down by 6. So that tells us, since that first difference is constant, we know that this is going to be a linear equation. And since we know it's a linear equation, we can come up with what the actual equation is. So y equals mx plus b. Let's see. We know our slope. The slope, remember, is rise over run, so you always want to pick the x value over, the y value over the x value. So -6 over 3 is a -2. And then since we have, okay, so then we're going to plug in an x and a y, so we know that this is 36 equals -2 times 0 plus b, because we want to solve for b. So we found out that b is actually going to be 36, which whenever x is 0, that is your y-intercept. But I thought I'd go through the process to review that again. So now we know the equation will be y equals -2x plus 36 for our linear. Okay, now let's do our last example. So we see plus 1, plus 1, plus 1. It's all good up here. Down here, when I subtract I get minus 8 here, so I'm going down by 8. Then I'm going down by 40. Wow. Then let's see, 376 minus 304, and again, you're going to probably want to have a calculator handy for this. So this is now going down by 72. This next one then is going down by 104. And then you're going down by 136. Wow, so we know it's not linear. But then, haha, here's where the magic happens. Negative 8 to negative 40, going down by negative 32. This one, 40 to negative 72, negative 32. Again, negative 72 minus, or negative 104 minus a negative 72, still negative 32. So the difference between these all is negative 32. So we know that we have a quadratic, and now we have to find the equation, which means we're going to be plugging it into standard form. Now we weren't given a gift, but if you choose 3 successive numbers, these work out really nicely. So we're going to start off with 424, that's the y value. X is 1, so this will just be a plus b plus c. The next equation will have 416, but x is now 2, so 2 squared is 4a plus 2b plus c. And our third equation, 376, so x is 3, so that becomes 9a plus 3b plus c. Notice none of your c values will ever have a coefficient because they're always just a constant. So what is nice about these is I always then take my middle term. I don't erase anything, but I show I'm going to multiply everything by a negative 1. So what I'm going to do is I'm going to add my first 2 equations, and I'm going to add the last 2 equations, and what happens is I then will have just 2 equations in just a and b, because c will cancel out. So when I do that, we are going to get 424 minus 416, that's going to be 8. Negative 4 plus a is going to be negative 3a, and negative 2 plus b is negative b. So that's adding the first 2. Now I add the last 2, so 376 minus 416, that's going to give me a negative 40. 9 minus 4 is a positive 5a. 3 minus 2 is a positive b. And because everything was just one number apart, the b's will always be set up just to cancel right away. We don't have to do any fancy footwork. So I add these 2 together. I get negative 32 equals 2a. So right off, I have a equals negative 16. Everything else now is just going to be back substitution. So if I go into this equation, I know that 8 equals negative 16 times a negative 3 is 48. So I know that b is going to be 48 minus 8. So b is going to be 40. And now we just have to find c. So we probably go back to our initial equation, the very first one, where we have 424 equals a, which is negative 16, plus b, plus c. So we want to solve for c. So 424, 40 minus 16 is, 24, plus c, and then we subtract 24 from both sides, so we get c is 400. When you're done, though, you do want to write the final equation, so we put it all together. So y equals negative 16x squared plus 40x plus 400. So we're going to keep those 3 by 3s going, but these are not bad if you get equations either that have a 0 for the x or the x's are sequential, 1, 2, 3, because your c's will cancel out right away and you're really just solving a 2 by 2.